Welcome to STEAM Powered, where I have conversations with women in STEAM to learn a little bit about what they do and who they are. I'm your host, Michelle Ong. My guest today is Dr. Kari Pitts, forensic scientist and mineralogist. Kari works with physical evidence, analysing the remnants of everyday life left behind at crime scenes. Join us as we speak to Kari about her journey to forensic science, working with physical evidence, and how it's not quite like CSI. Good morning, Kari. Thank you so much for joining me today on STEAM Powered. It's wonderful having you speak with me today all about your work in forensics.
Thank you. Thank you for having me.
Excellent. So you got started studying in forensics and analytical chemistry at university, but what motivated you to do that?
So I told my mum when I was 4 that I was going to be a mad scientist when I grew up. And I like to think I'm as legally close as I can be to being one. That's what I like to do. Yeah, exactly. I was about 4, running around. I was born in Paraburdoo, up in the Pilbara, up north, running around predominantly outside, but always fascinated by everything. My favourite question, and the question that I bugged my dad with repeatedly, was why? Why is this? Why is that? Why is that? Typical, He always said that he couldn't get anything done with that little blonde head popping up and going, "What doing?"
Yep.
So that it's kind of tumbled into a fascination with science. In primary school, I had very science and maths driven year 4 and year 5 teachers in primary school, and they really challenged me in terms of what I could do and what I could learn, and sort of that fascination, and still fed that childlike curiosity, but also pushed me to go, okay, well, you want to know why, go find out. This is the resources that you need. This is the types of questions that you need to ask. Go find out. And so when I was at high school, looking around at what to do, chemistry was by far my best subject. We're talking like a 15% difference between chemistry and everything else. So it was logical for me to go into chemistry. I like it. It's logical, but it's fascinating because you can't technically see it. You can only see the byproducts of it.
Yeah.
So looking around at what to do at the end of year 12, basically, you've got to pick your subjects. And Curtin University were offering a brand new course in forensic and analytical chemistry. And
Nice.
I'd liked the questions of the analytical chemistry, determining why and what and how. So having that forensics, I wasn't really sure what it meant. CSI had only just come out, and I was like, I don't think that's particularly real life. But it's one of those things that you go, well, we'll give it a go. And so I put in to do forensic and analytical chemistry, and I was one of the first batch of students in Western Australia to start the degree. We did lots of chemistry, didn't touch anything really forensics until 3rd year. It's a little bit different now. The same course is still offered. It's offered as a major within the chemistry degree. But basically was, really liking the chemistry, was still quite good, and so was able to get the grades that allowed me then to go into honours and do an honours degree in forensic chemistry. Loved the project that I was working on, loved the supervisor that I was working with. Wasn't quite ready to get a proper job, so applied to do my PhD and got into that, and then finished the PhD and started here at ChemCentre. So that's where I've been since 2006.
That's so cool. So what does forensic chemistry involve at the course level? Like what makes it forensic?
In a nutshell, forensics basically means what traditionally it means of the forum. And that's ancient Greece. It's, where the trials were trialed by a decider of facts based on a group of peers. And nowadays, forensics means anything applied to the law. So you can put forensic in front of everything. And as long as you've got the base science and the scientific knowledge there, you can then apply it to the law. So forensic chemistry is chemistry applied to the law. Now, my area of forensic chemistry is trace evidence. So I do physical evidence. paint, glass, gunshot residue, arson accelerants, lubricants, fibres, and soils and minerals, which is a little bit different than some forensic chemists would be, because I have a geology background as well.
Mm-hmm.
So forensic chemistry overall is any type of chemistry applied to the law, but my specialty is trace evidence.
That's very cool. So did they actually cover the legal aspects as part of the course?
The degree was very heavily chemistry. You have to have the base science.
Yeah.
You have to be able to understand why the tests do the things that the tests do, and why the results are the results are. Yeah, but in terms of the forensic aspects, it's things like chain of custody, and evidence laws, so what you can and can't say about particular things. But all of the things that are forensic focused are usually dealing with the law side of things rather than the science side of things. So it's a lot easier to understand the base science first and then do the forensic aspect, because you're then applying your knowledge to the actual law that way.
That is very, very cool. Yeah, because it gives you a different perspective on the way that you approach your materials and you approach your samples, because of the way that you have to consider things like chain of custody and all that other stuff. That's very cool.
Definitely. So you've got to be able to prove that what you're analysing is what was originally found. So there's a large amount of work that goes into that proof of chain of custody. Evidence sealing at the crime scene, or wherever, and then all of the paperwork and all of the proof as you follow that exhibit where it's been, to ensure that what I'm testing is exactly what was seized or what was the actual sample to start with. You've also then got the complicating factor that forensics is history. It's already happened and you're trying to reconstruct what's happened. So therefore you've got things like a risk of contamination, you've got the risk of things changing, and you've also got a major risk in the fact that what you have might not necessarily be representative of the original sample. So say, for example, soils. Someone walks through a muddy lot. The issue is the sampling method that I have is someone's shoe rather than a nice shovel or a nice clean area.
No control environment.
I don't have the ability to go to the suspect. Can you just take a shovel and give me a little bit more of that sample? The sample is what the sample is. So I can only do so much, and so I have to be aware of the limitations of my techniques, but also the limitations of the sample itself as well.
Yeah, that's very interesting, especially because, I mean, even under normal research circumstances, your samples are your samples, and you're still, having to deal with time and all the other things that might affect the quality of your sample over that period. Yep. But yeah, because you have no control over the source in this case, That's
so when you're doing research, you do all of this quality control and all of this limitations of variables. In forensics, you don't have a choice. You can try to minimize as much, like you try to make sure that your sample is packaged appropriately, that you don't lose part of it. So say with a fire debris from a house burn, when we get the ignitable liquid residue samples, they're in a container that is meant and is designed to prevent the loss of vapors. So that's one way we can be assured that what was at the scene is what we're analysing. Clothing, for example, if it's folded in and put in with some other shoes, you've then contaminated with whatever was on the shoes. Yeah. So you've got the risk of maintaining that capability or maintaining that integrity of the sample by all of the packaging products, which sometimes we have no control over.
Yeah, because you're not the one doing the collecting.
No, and that's sometimes the situation that we run into. Is the way it works in Western Australia is the police or the crime scene officers go out to the crime scenes, and their job is to collect and record and package all of the evidence that may be of interest in that particular case, and then they send it off to the individual laboratories for analysis. ChemCentre does some of it. Pathwest do forensic biology. So they're doing the DNA testing and the blood testing. So they'll have particular processes that they need to ensure are done. And then the police have their own in-house laboratory for things like fingerprints, ballistics, and tool marks. So depending on where it's going, you might need subtly different ways of packaging or subtly different ways of taking a sample. And that can cause issues. Sometimes you open up an exhibit and you're like, oh, this is not what I was hoping for. But it is what it is. You do your best that you can do.
Yeah. So because each kind of lab or each group of the types of evidence has to be handled in a different way. Can there be more standardization, or is it just the nature of the materials and the evidence that you're working with?
So we work obviously very closely with Pathwest and with the WA Police. We do some training into the police officers in terms of what we would like from them. They have their standard, referred to as standard operating procedures, SOPs. So those SOPs will actually outline the requirements. But sometimes they can be a little bit not quite right. And so it sometimes is that we actually will get phone calls from a case officer and say, look, I've got this particular exhibit. I'm not quite sure which, who's going to get it first, or what, like how to package it. And so we can then consult that way. So we will occasionally get phone calls from case officers at crime scenes going, how do I sample this? Or how would you like me to package this so that it doesn't interfere with your analysis or the other analyses that are going to be done after yours.
Afterwards, that's very interesting. Yeah, because do the technicians have to be trained in like the foundations of what you do, or are they scientists themselves who happen to be working in those jobs? Or?
So the crime scene officers themselves, so there's usually two levels of the crime scene officers. You've got the general volume crime SOCOs, scene of crime officers. They're the ones that will go out and process the volume crimes, the break and enters, someone steals your stereo, breaks a window. So they're quite
fairly straightforward
in terms of they're looking for DNA, they're looking for fingerprints as a first pass. And then depending on the actual case circumstances, they might collect some glass or they might collect some other bits and pieces. So in that particular case, they're following their SOPs that we have some input into, but are predominantly WA Police focused. The major crime guys, so the forensic field officers, they are the ones that respond to major cases, homicides, severe sexual assaults, aggravated burglaries, grievous bodily harms. And they are more trained in terms of what we're capable of, what Pathwest requires, and we also will do refresher training with them, and we have a good relationship with the forensic training and forensic training and development unit within WA Police, specifically to aid in their training as well.
That's very neat. So with the evidence, because, they do have to think about, multiple tests, multiple labs, is there an order, or does it just depend on what it is?
It's normally, there is kind of a preference. It goes for fingerprints, then it goes for DNA, and then it will come to us, depending on what it needs. But in some cases, it needs to come to us before it comes to anything else, or in some cases, it'll go to fingerprints and then to us and then to Pathwest. So we have to be able to take examinations or undertake examinations under DNA controlled conditions, and we have that training, and we've worked with Pathwest to develop those processes to ensure that we're not contaminating it. In addition, my DNA is on the DNA database at Pathwest, so if I do contaminate
it can be excluded.
it can be picked up, and I'll get a please explain. So it's really depends on the case, but there is a fairly typical order. You do the ones that are most likely to give an identification first, because obviously they're faster and cheaper. So DNA and fingerprints, usually fingerprints first, because they do the powder and then they can swab for DNA. And then we'll get the exhibits after that for things like fibres or paints or whatever. So it really does depend on the case circumstances. And sometimes I've even gone to Pathwest, and we do what's referred to as a collab, where I work with their DNA scientist to process the exhibits together to make sure that we're capturing both types of evidence, the trace evidence as well as the DNA evidence together.
So much fun.
Yeah, it's good. You'll probably hear me talking a lot. I love my job. It's one of I feel incredibly lucky to still love it 16 or 15, 16 years after I started here. I've been doing the same job for the whole time, and I can't imagine leaving it. It's one of the things that is very, very lucky to have kind of fallen into the area that I'm in that it's just, I can't love it more, basically.
Yeah, absolutely. Because, even though, you've got procedures, you've got workflows for everything you need to do, but there's always something different, and there's always a different puzzle to solve.
Definitely. And so within ChemCentre, we do different types of chemistry. We have the toxicology section, so they're looking for chemicals or drugs or materials within a biological matrix. So they are quite routine in terms of their sample preparation. You take your blood, you extract it, you run the extract. The interesting part comes from them in what they find.
Yeah.
Then we've also got the illicit drug section. So they are doing all the seizures. Again, it's a fairly standard process that they go through. The interesting part comes in what they find again. Within trace evidence, we just do so many different things that we get basically anything that's not biological, not radioactive, and not a drug, we can do some form of analysis with. So it means that one day I'll be looking at gunshot residue, the next day I'll be looking at soils, the next day I'll be looking at glass. And then you get the weird ones that pop up. You get a case officer saying, I just need you to analyse this, and this is going to be important for a case. You get some weird requests. But that being said, so I had one come through the other day. They're like, can you analyse a seashell? And I was like, okay, yeah.
It's very specific.
Yeah, it was like, we've got this seashell that's come in, and we need to be able to, we've got a bit of it, and then we've got the rest of it, and we need to kind of group or compare them together. Quite often there is a question versus known comparison in trace evidence.
Yep.
And so as a consequence, you just simply break it down into its chemical components and look at how we can actually analyse those components and what type of discrimination ability that would be. It so happens that I have experience previously using these techniques within the area, not for forensics, but for a research project that I was involved in. But it's amazing what happens when something random pops up. So I seem to be the one in the laboratory that just gets the odd cases. So I've done things, I've done face paints, I've done egg, I've done inks and hair dyes, I've done vomit, I've done like just all the weird and wonderful ones I seem to get.
That's fun. So tell me about the egg.
I obviously
egg.
Exactly. So in this particular case, I have to be, obviously within forensics, I do need to be a little bit cautious about what I actually talk about. So I can't use identifiers, and I can't discuss cases that are still within the court system. But in this particular case, there was a number of eggs that were broken in a house. And the alleged offender was saying, I wasn't in there, I didn't have anything to do with it. So the case officers seized the shoes of the offender and said, is there egg on the shoes? So thinking about it and doing some research and saying, okay, well, how can I determine if there is the presence of egg or not? And we have within our section, within ChemCentre, we have a racing chemistry section, and they obviously do immunoassays. So they're looking for almost a biochemical reaction. So I went looking to see if you could find an antibody that was specific for egg albumin, so chicken albumin. And funnily enough, there is one. So I did up a small little agar plate, put a hole in it, went to Coles and bought some egg and came back, dried the egg, did some testing, and sure enough, you could actually see when I dosed it with the antibody, it made it precipitate. You made this immunoassay response to the egg, did a blank, confirmed that it was only the egg that was actually producing this reaction, and then went from there. So yes, there was egg albumin present on the shoe. So
that's interesting.
It was a weird one. It happens every now and then.
That's very cool. Yeah,
it's using the scientific process to work out and answer a question. Most primary schoolers would understand that concept of, okay, I've got a question, how do I go about answering it? So you've got to do it in a scientific, methodical approach, showing at each stage that the answer is what the answer should be, and then going through your thought process. So as long as it's all documented, we have under our NADA accreditation the ability to do these types of weird ones, as long as we are open with the limitations of the exercise. So I couldn't necessarily say that it was definitely chicken egg, because there would have been potentially turkeys or other within the actual phrase that would have given that same response. And I didn't.
It was an
it
egg.
was it's enough that it was sufficient to answer the question.
Yeah, that's interesting. So with common enough substances though, like how would you go down excluding even further? Like say it was meant to be like a duck egg and you could still test for that it was, egg albumin, but how do you get even narrower when they ask you these very specific questions for seemingly common substances?
That's where the chemical knowledge comes into it. So say in that particular case, say for example, proving it was a duck egg versus a chicken egg. So what I would do is I would look for research within the published literature that looked at, can you differentiate chicken versus duck, or what is something that's present in duck eggs that's not present in chicken eggs. And it may be that there's a particular protein, and we have a protein ability analysis lab here. It may be that there's a particular color or there's a particular compound that we could detect. And so you would be looking for those points of difference. And the issue within physical evidence where I work is we're dealing with a lot of mass-produced products. You think about how many samples or how many tins of paint there are at Bunnings. Exactly. How do you tell them apart? And what you do is you do a series of analyses with different instrumentation that looks at different aspects of the paint, and at each stage you get a level of discrimination. When you tie those all together, say for example you start with white paint. Okay, you go, I've got white paint. Okay, that's great. It's white paint. It's everywhere.
That's nice.
However, yeah, exactly. A white paint. Woohoo! Yeah. For us, that would be considered fairly low evidential value. But if you say, okay, it's white paint and its binder or its glue that holds it together, it's an acrylic paint. So straight away, you can rule out all of the oil-based paints. It's not an oil-based paint. It's acrylic paint. Okay, so now it's white paint with acrylic. Okay, so now in addition to the acrylic, we look at the pigments. It contains titanium dioxide and barium sulfate and calcium carbonate. Now, they're all three fairly common pigments, but finding all three is a characteristic that not all white paints have. And then if you really wanted to take a step even further, we could look at the impurities or the trace level impurities that are within that paint itself that are characteristic of the geochemical location where the titanium dioxide was first mined, and then all the refining process that it's gone through. So you can get down to that really strong level, which is what we do with glass. Don't routinely do it with paint because paint has its own issues, but at each step you're looking at how much within the general population or how many other samples are the same. And sometimes we have to be, it's blue cotton, or it's one of the most problematic things we have at the moment is colourless cotton. You think about how common cotton is in the environment, and white cotton or colourless cotton, because it's not actually coloured. This colourless cotton or white cotton is considered just useless because you can't do anything with
Yeah,
it.
there's no way you can isolate it.
Yeah, but if you really wanted to, and it was really important, there are techniques that have been developed that are published within the scientific literature that we could potentially go down. So you
But obviously
can
those get more expensive as the more
more
detailed you have to
expensive,
get.
more time framing, exactly. So for us,
Yeah.
we'll start with the basics, and if we can discriminate at that first level, then you don't need to go any further. You save some money, and we also save our time. So
Yeah.
at each step, you're looking at that next level of discrimination. So people always ask me, what's your favourite instrument? I don't know if you it's a microscope. Yeah.
That's cool.
All of the things. So I work on instruments that are worth over $1 million, but my favourite instrument is a microscope, because if you can see it, you can get some form of information from it, and it's the first step in any forensic analysis. Look at it. What does it look like?
That's awesome. So because some of these processes do become very expensive in terms of money or time, have you ever come across or come up against budgetary problems in having to, figure these problems out?
Yes, there is always a thought process that, in terms of, is this cost justified for the case itself? So yes, we do have occasionally case officers that say, okay, that's sufficient, we don't need to, it's not necessary to go any further because we have DNA or we have fingerprints, therefore your analysis is no longer required. But that being said, we are an independent agency away from the police, so they can say we don't recommend it. But if I think that it is justified and required and will limit my opinion, because that's obviously what my report is my opinion of the evidence. If I believe that the analysis that I have done is not sufficient to make a proper opinion, I will then just go off and do it. Especially within the instrumentation that we have within the laboratory. We are well equipped in terms of our instrumentation and our expertise for that instrumentation. So yes, there are obviously, I'm not going to be asked to do a really, really long, extensive analysis costing thousands and thousands and thousands and thousands of dollars for someone who's had their window broken. It's not justified. But that being said, if that offender has then broken multiple windows and they have that evidence, then it may be that that is what's required. So in terms of my cost and my expertise, yes, I am expensive, but in some cases I am what's needed, and so therefore that's why I'm here, is to do those types of analyses where DNA and fingerprints are not enough.
Yeah, and that's fascinating as well, because as part of your job, you do have to, present in trials and in court.
Yes, I testified 2 weeks ago. So, and that is part of our training, and it's also part of the forensic training that you get, is explaining your science to juries, because that's sometimes where a lot of high-level scientists struggle, is how do you explain your science to someone who doesn't know your science? And as a consequence, within forensics, we have to testify as an expert witness. We're there to aid the jury and or the judge or the case officers themselves in terms of understanding what our evidence is, how we've done it, and what it means, the strengths, the limitations, our interpretation of that, and we will have to go to court to testify. So I get suited up, I go along and I give my qualifications. I'm qualified as an expert witness, and then I'm led through the evidence that I have in terms of what I've done, what techniques, and what does it mean in terms of, typically it's a question versus known. Sometimes it's an identification. It really does depend on the case as to whether I'm even required or not. In some cases, I don't go to court all that often. I think in my 15 years here, I've probably testified about It's probably close to 30 times now, which is not that much. It really does
Because
depend
most of
on
the
the
case
cases.
because most of the time you submit your opinion, and that information is adequate for whatever process they need to conduct. So
Yes.
you see on television that sometimes they can get quite hostile towards all of the scientists and the evidence. Like, does that come up, or is it usually more straightforward question answer type thing?
It depends on the defence lawyers.
Yeah.
I've worked some fairly high profile cases and testified into these cases. But that being said, it's still a professional situation, and so we're not there as a personal. We're not there as a person. We're there as an expert. So as a consequence, if they are questioning, they're not questioning me. They're questioning the science. And so I do pride myself on ensuring that the limitations of the techniques that I'm dealing with and that I'm using are clear, but also not understating the evidence. And that can be a challenge, especially in cross-examination or normal examination by the prosecutor. You can't overstate the evidence. You can't say, yes, this hair definitely matches this person. Well, no, because you can't say that. You can't say that because you don't know how many other hairs from how many other people would look exactly the same. The very risky part of forensic hair analysis. The FBI has been criticised and admitted that there was a major issue in the way that they presented their evidence. That being said, though, finding a dark hair when an offender or a victim is blonde, that is a distinctive difference that is actually of evidential value. So not overstating the evidence and not understating the evidence, but also just engaging with the examination and the cross-examination in a professional manner. So I've never been personally attacked, and I've had questions, do you agree with this? Do you agree with this? And you can say, yes, I agree that in this particular circumstance, I don't know how many other cars would be painted exactly the same way. However, what is the likelihood of finding that particular paint at that particular time, at that particular place, with the other one or the other paint being transferred both ways? So as I mentioned, you can't overstate the evidence. You can't say it's miraculous, it's definitely this, because science is not like that. There's always going to be that level of uncertainty. But also it is useful evidence. You just have to ensure that the jury or the judge and the lawyers are clear on what that use actually is.
Yeah, that's very, very interesting. Was it because you did have to get training to be able to present in court? I know some people who would find that very challenging as an experience. Like, is it just something you get used to over time?
I think it depends on the person. So for me, I never really had a major problem public speaking. Through primary school, through high school, when we had to do, you have to do those presentations, we have to do an oral presentation, and there'd be people in my class that would be absolutely petrified. I was very lucky in the fact that as long as I had prepared something, I didn't learn it by rote, and I still don't learn things by rote. I can't work like that. I have to kind of have touch points that I know I need to talk to, but then I just kind of wing it. So for me, I would get very, very nervous 2 minutes beforehand. So I worked on those techniques that help me relax immediately at that particular time. I'm fine in the lead up. It's that 2 minutes that I just go and so for me, that's what I worked on. And so I would practice when we first go to court and we start the training within it. You're asked, you have to go through a series of standard questions. Do you swear to tell the truth, or do I affirm to tell the truth? Do you swear or affirm your testimony? So I kind of practiced that a little bit. It's better now that you can can actually read it, so that's nice. I can and that helps me calm down. So I've learned that I can read the affirmation, because I don't swear on a Bible. I affirm instead. So it's basically my promise. So I can read the affirmation, and that helps me calm down, because as I'm walking into court, there's the lawyers, there's the defendants, there's the judge, there's the jury. I'm walking in.
A lot going on.
Exactly. So I focus on shoulders down, putting my case file down onto the desk, holding the affirmation, and slowing down my reading of the affirmation.
Yeah.
Once that happens, the next thing is my name and my qualifications. So they are the things that I have practiced to help me relax. Once I'm into it, I'm fine. That's not a problem. Although occasionally I stumble over analogies. The one that I went to a couple of weeks ago, I went down the rabbit hole, and I was sitting there going, just stop talking, stop talking, stop talking. But we got around the right way. It was only afterwards that I was like, oh, that was a perfect analogy. Why couldn't I think of that at that particular time? Always happens. But it's within our training, we go through those things of, what to expect. We go to visits for a courtroom. We do mock simulation testimonies as part of our training to go through and say, okay, well, what happens if they ask this? Or what happens if they ask that? And then you also have, typically, depending on the case itself, you have a pre-trial meeting with the prosecutor, who will go through your evidence and ask the kind of questions. And if you are nervous, especially if it's your first or second time, like we've got some junior chemists that have done that recently, and being able to discuss it with the lawyer and say, okay, what kind of questions are they going to ask me? You can also then work on bringing down your anxiety levels. But I'm very lucky in the fact that I have had lots of training, and my personality within that sort of space is I only get nervous right at the start, and then once I'm in, I settle down. So, but there are others that have had to have specific training. We have voice training, we have anxiety training. So it depends on the person as to what you are. But there's always mechanisms and always things you can do to help you with that type of pressure. It's just working out what works for you.
That's great. It's nice having you so prepared. Because it's an entirely different environment. When you're a scientist, you go, I'm going to be a mushroom. I'm going to do my work and get things done and figure things out. If you present at a conference, it's a bit different. It's sort of one way, you get question time, but, it's an entirely different environment to having to, present in that fashion in a courtroom. And
definitely,
it's a different sort of mindset that you have to have when you approach that circumstance.
It is. And it has meant that all of my outreach, so I'm very, very passionate about doing a lot of outreach in terms of the fact that I think that kids have the best ideas and the best engagement in science right from the get-go. Like, I've got 2 kids myself, but even before them, I was heavily involved in outreach, because I think it's important for them to see all of the different options that they could possibly do when they get to be grown up. Because I never knew that my job existed when I was going through primary school and high school. It was,
that's right.
Forensics was non-existent. I didn't know what it was. But it also helps me, because if I can explain my science to a child, I can explain it to a jury. Hopefully.
That's right. Yeah. You said that, CSI was still fairly new when you started in university doing this course.
Showing my age a little bit. So
right.
the CSI had only just come out, literally just, I think it was like a month or something before I graduated. So it really had so it was, I graduated high school in 1998, if you would like to know how old I am. But
that's okay, me too.
Yeah, good year. Being an 80s kid, it's one of those things that you saw the detective shows on TV, and you saw the cop shows, and it was all very high level stuff and very exciting and very action packed. And then this new TV show came along, and I'd seen and I'd read Sherlock Holmes, I'd read Patricia Cornwall, and I'd read all of those other sort of crime novel bases through high school.
Yeah.
And so I went, well, this TV show has only just come out. I wonder how close it is to real life. And looking into it nowadays, I got banned. My husband won't let me watch CSI with him in the room because I start yelling at the TV. That's not happened. That doesn't happen like that. That takes a week. That is not the answer to that, you know. When they start talking about and you can see the techniques that they've learned by rote, you know, it's the gas chromatography mass spectrometer. And you're like, we call it a GC, like, you know.
Yeah.
But for me, the interesting part of that is I can then use it to engage with the general public. So now I talk about NCIS, or I will talk about the other type of, you know, sort of science, true crime sort of based ones.
Yeah.
And I can
use your
use
frame
it
of reference.
I can use it. You go, okay, well, you know NCIS, and they'll go, yeah. I go, you know Abby, yeah. She's in the lab, right? Yeah, that's me. Except I don't have all of this expertise. I have this tiny little bit, you know.
Yeah.
And so they are semi-realistic. It's a TV show. They take that, they take the real life, and they just extrapolate it extraordinarily.
Yeah.
But it starts with the real life actual situation. So it is useful in that respect in terms of, yes, CSI is, you know, not actually how it happens. My husband, you know, as I said, I yell at the TV quite often, but it shows the science as a starting point. It's just obviously not realistic, but it's enough to gain your interest, which is exactly what you want in some of these types. It shows the options. You know, Abby is, yes, she's an expert in everything, but she is an expert in ballistics. There are people that I work with that have that particular role. She's an expert in computer science. Again, this one person has a miraculous knowledge, but she has that expertise. I know people that do that. She's a toxicologist because she can look for things in blood. I work with those people. You know, and she is me in terms of the tiny little bits and pieces of stuff that she happens to find that miraculously match this thing in the database. But we won't go there.
Yeah, because it's those things, like they can't, you know, have this ensemble cast of 6 million people.
No.
So they, you know, they have this one person who's meant to be representative, and, you know, gives you a taste of this is the sort of thing that happens.
Exactly.
But it does glamorize it a little bit too much.
Oh yeah, they walk through the laboratory or through the crime scene with their long flowing hair, fully maked up, no glove, or they might occasionally put gloves on, but they're not wearing bunny suits, they're not wearing masks, they're not wearing all of the PPE that I would. You know, so it's definitely, take it with a grain. It's good, but it's not real.
It's a start.
Yeah.
If
it gets you interested, that's enough. You can use that as a starting point, which I think is kind of where I thought about it. And honestly, when I started my degree, we got told forensics is incredibly hard to get into, and it is. It's very hard to get a job in forensics because it is such a cool job, you know. So you are competing with lots of other people. So I got told, you'll never get a job in forensics.
Wow.
But I've got a chemistry degree. So that's where I thought that I would I wasn't sure what I wanted to do and where I was going to go. And so for me, it was, okay, well, do I actually like the work and like what I'm actually learning? And the answer was yes. So that's why I stuck with it. So to put it in perspective, there was 20 of us in that first year degree intake. By second semester in first year, there was 13 of us left. 5 of us graduated.
Oh, gosh.
And I am the only one that's working in forensics of those 5.
Oh, wow.
So
those are really tough numbers.
Yes, but it's a little bit different now. It went through a phase where, and that's, everyone asks me, I quite often will get asked, how do I do your job? You know, how do I get your job? And the answer is, chemistry degree with the forensic extras afterwards. If you don't have a chemistry degree, I can't hire you as a staff member. because we are a
Because you're a
chemistry
chem lab.
organisation. I am a chemist first and foremost. I don't do forensics first. I do chemistry and geology, but chemistry first. Chemistry and geology is my area of expertise. And so people will ask me, I was like, do you like the base science? Or, well, if you don't like the base science, don't worry about it. If you like biology, do biology. You can do forensic biology. You like geology, you can do forensic geology. You like computing, you can do forensic computing.
Forensic finance. Like there's so many different ways to do
So
that.
many different ways. But if you don't like the base science or can't do the base science, you will never be able to be competitive in the job market to get those roles. And it's better than it used to be. You used to have to wait for someone to die or retire to get a job in forensics. With the change in the generations, it is actually a little bit easier. It's still competitive. So what I normally say to people is get your base degree, then you are competing. So technically you could get my job with a 3-year degree. That's the minimum. But you are competing with people that have these PhDs or the honours or the masters. So that's where you can do
things.
Exactly. That's where you can look at the specialisation or what you really are interested in, or that real sort of forensic stuff can come after. So, but if you don't have the base degree, it makes it very hard for employers to employ you.
Yeah. So you said that things have changed since you had to enter the workforce. So what sort of changes have occurred that have made it less difficult, though still difficult, to get in?
So there's been basically, I have seen within, so when I was going through undergrad, I think I had, over the course of my 3-year degree, I think I had maybe 1 or 2 female lecturers. The rest were males. When I started here at ChemCentre, I was the only female in the section. It have been for a while, but that's changed now. The last 3 years or so, we've had a bit of a shuffle within forensic or within physical evidence. We're a very small team. There's only 8 of us in total. So for a while there, it was myself and 5 other males. But within forensics as a whole, there's definitely been a very strong shift. We are now predominantly female. A large amount of our employees at ChemCentre within forensics and within chemistry or science in general has been female. ChemCentre itself is actually 51% female.
That's interesting.
So there has been that shift and that push towards inclusion, and we get flexi time, we get paid maternity leave, and so as a consequence, being state government, we have seen that change, that females are more and more and more supported within that particular role.
Yeah.
We now have a director of a particular department as a female. We still have 2 more directors that are males. However, at that next level down, it's within forensic chemistry, it was 50-50. We actually have a vacancy at the moment. And then at that next level down, it's again sort of team leader level. So CEO, then director, then manager, then team leaders. Most of the team leaders, I think it's 50-50 pretty much now, or near to it. That generational shift has seen more females coming into the workforce. It's also seen a bit more of a turnover, in that the fact that you don't start straight out of your university degree and then just never leave, like you're here for like 40 odd years. We have seen people shift and move, and they move job roles, or they'll leave ChemCentre. So there has been that change in the fact that if people aren't happy or people want to do something else, they have that option to leave. And so therefore that allows more people to enter into the ChemCentre workforce specifically, but in terms of the wider scale of things, there is just that generational change that you've seen within that sort of my time frame of being here, that I've gone from the very young lady that was, terrified of talking, to now that I've kind of got more experience and become more senior, I know that my opinion is now valued, and
Yeah.
that I can contribute, and that I am contributing and have contributed long term to where we are within an organisation, but also where the science is
Yep.
as well. So
That's great.
forensics is one of those fields that is quite heavily dominated with what's probably not dominated, but there is a large contingent of females within the
Mm.
actual within the group.
Yeah. And it's interesting because part of it isn't always about the interest, but about the work environment and being conducive to supporting the flexibility or the fact that there are going to be different phases in life that we do, go through for
Definitely,
different things. So
exactly.
yeah, it makes it a lot easier, or easier in a relative
Easier,
scale,
yeah,
to,
easier.
yeah, to be able to consider some of these jobs. Because I've spoken to some people as well who went, well, I started off in computing, but I left computing because it wasn't an environment that was conducive to me wanting to live my life in a different way.
Definitely.
And yeah, so having that space and the flexibility in the work environment to be able to do that makes the entire field a lot more enticing.
It does, yeah. And
Mm,
obviously, it depends on the organisations.
yeah.
I work for the state government, so
Mm,
the ChemCentre is a state government organisation. It provides forensic and analytical chemistry services to the state of Western Australia. And as a government agency, obviously, we do get those perks of being a public servant.
yeah.
That being said, though, it really also does depend on the managers and the directors that are
Mm,
involved. So it
of course.
really can vary from organisation to organisation. But I have seen, again, a shift in that my boss has always said family comes first,
Mm,
regardless of the situation, family comes first. I'm sure that there are other organisations that might not be as tolerant, and there within ChemCentre there are obviously other teams or other sections that might not be as flexible in terms
mm,
of the requirements of the job themselves. And
yeah.
so for me, I've felt very, very lucky that when I had both kids, I was able to take the maternity leave that I wanted to, but come back to a role that was exactly the same as when I left. I had
Yeah.
no concerns and no issues returning to the workforce. Whereas I know
Mm,
that there is still within that STEM area massive risks, especially in academia. I've got so I'm one of the 2019 2021 superstars of STEM, and so
mm,
just talking with the other 60 people that are in that program, it's terrifying to see how some of them are treated still within their area, that within forensics we are actually able, or within ChemCentre and other organisations like us, we are actually able to deal with these types of situations, and
yeah.
being able to say, I am a person first
Mm,
and then a scientist. There are
yeah.
some times and there are situations that you can't keep going. You have to be able to take a step back and say, no, I need help, or I need to be able to focus on this particular aspect of my life. And I've had that happen. I
Yeah.
have multiple times had to sort of go, I just can't do this today. I just need to do this instead.
Yeah.
And that's fine. The issue, I think, we need to make it that that's not a problem anywhere. It
Mm,
always needs to be that in any workforce and in any job situation, the person is treated like a person first and
yeah.
then a worker. So fathers can take paternity leave and not feel like they're doing the wrong thing. Mothers
Mm,
can take maternity leave, or mothers can go to conferences and aren't being made to feel guilty for not being at home with the kids.
yes.
It's you need to basically make society or make that culture around STEM. And I know some areas do it better than others, but
Mm,
for everyone to be accepted, everyone has to be treated as their own person. And I
yeah.
think that in some cases is definitely what's lacking in the STEM field itself, is basically just showing and having that support and that ability to say, I need this,
Mm,
and then working with it to actually get what you need to keep the person in
exactly.
the workforce.
Yeah, because we're multifaceted people, and there's so many different aspects to our lives other than what we do for work.
Yeah,
And it people keep talking about, brain drain as, the generations change as we get older.
Yeah.
And it doesn't help when people don't feel that if they do have to switch away, or if they have to take maternity leave, that coming back is a problem, or, they have to skill up again. It makes things very difficult because they have all that
Very.
foundational knowledge and they can use it.
Yeah, and
And,
if
it's a waste.
exactly, if they don't feel supported, if they don't
Mm,
feel secure and supported in their job, they'll leave, which
yeah.
is they're allowed to.
Mm,
But that's why you get this leaky pipe. We spend, and I spend all this time doing outreach with children to get them into the STEM fields because I think it's important and it's,
mm,
my passion. But if they're not
yeah.
supported once they're in there, they'll leave. And
Yes.
that's an issue. It's a major issue within the STEM field, is ensuring the longevity of the careers of the people that put in
That's
the
right.
effort to get there.
Yeah, there's a lot of personal and financial investment in getting to where we want to be, and
Definitely.
having to abandon that or being burned out is, it's a waste of your potential.
Definitely, and it's an absolute shame because who knows what
Mm,
those people could contribute if they, once they're lost, they're gone. You lose them, so therefore you get that survivorship bias of, well, this is the way it is. You just have to deal with
yes,
it, and I
exactly.
hate that. I absolutely
It is.
hate that.
Yeah, it's yeah, it feels bleak.
It does, and I'm very lucky in that I can see the change, and I have, in some cases at the moment, the ability to influence the staff that
Mm,
are reporting to me. So I will always try to take the mindset of the person comes first. Uh,
yeah.
and I want them to feel safe and secure enough to say, I need this.
Mm,
That's what a whole manager or a team leader, or whatever, a person in general does. Um,
yes.
we're social animals, social beings. We can't just keep a head down and plodding along. That will only work for so long before
Exactly.
something has to break, and we don't
Yeah.
want it to be the person.
Absolutely, we don't want that. So, we're talking about how, some people have transitioned out of ChemCentre, and, the graduates who graduated with you didn't all enter forensics the way you did.
Yep.
So what are the other opportunities are there for people, if they don't get into forensics, especially,
Ah,
as a civil servant, or, if, they end up, having to, transition out of ChemCentre to do something else?
yep. So within, obviously, within my degree, we are still chemists. We could
Mm.
still work. Like, I could make a lot more money. I am a state government employee. I could make a lot more money going mining industry because there
Yeah.
is the need for the chemical expertise within that space. So we were
Mm.
told there are options, and even though I was doing a forensic degree, I would
Mm.
still qualify as an actual chemist. So
Yeah.
that was for me an option, and that's where some of the other people have gone. One's a high school teacher, one's a lab tech, uh, one works
Mm.
for a chemical company, and another is actually, she joined the police service. She went and joined the police service. I'm not quite sure where she is now, but that's what she wanted to do. So
Yeah.
you still can use the expertise that you have within a STEM field. We are still scientists. We can
Mm-hmm.
move within areas. So those people that have left ChemCentre to go on to other options, they've gone private sector, they've gone to other government departments. So Department of, sorry, lost the mental blank in terms of where they've gone. Dangerous goods. We are
Ah,
chemists. We
yes.
can move into dangerous goods or mining industries or mining
Mm.
regulations, Department of Water. So all of these other scientific applications we are still qualified for. So
Mm.
within our sort of aspect, and that's again another reason why I say to people, base science first,
Yeah.
because if you end up with just a very, very focused forensic
You're
degree,
entering a very small market
there's a
for,
very, very big bottleneck that you'll get stuck at. Or, you might be
yeah,
lucky and make it through, but at least if you've got the chemistry degree, you've got these other options. Or if you've got a
mm,
biology degree, you've got these other options. Computing degree, these
absolutely.
other options.
Yeah.
You're not tying yourself in. And it's also good for you because it means that you've got that wide range of expertise that makes you a
Mm,
valuable employee because you've learned all these
absolutely.
other things. You never know what's going to pop up. You could one day be
Yeah.
examining eggs.
Precisely. And yeah, so you've got private sector, you've got public sector for forensics, and it's great that you still get the ability to specialize in forensics to be able to have that broader range of experience because even if you're not doing forensic sciences in whatever other job you're doing in that foundation,
Yep.
you still apply those principles anyway. Like
Yeah,
it's
exactly.
not useless skills.
No, and that's I was involved a couple of years ago with a state government, basically a state government goal of making or of encouraging year 11s and 12s to study STEM subjects.
Mm,
And for me, the scientific or the STEM basis is a way of thinking, not necessarily a job. And
yes.
so, if you have that experience, it can be applied to all of the other things that are
Yeah.
outside of my expertise, but I understand the scientific process. So, understanding things about vaccines, thinking about climate change, thinking about how the social sciences or the social areas of things, thinking about them in a scientific way
Yeah.
is is my way of thinking because of all of the STEM training that I've had previously. So
Absolutely.
I think it makes me a better person because I have that STEM knowledge.
Yeah.
And that's that STEM sort of mindset, which is in some cases a challenge.
That's right. And it really is a mindset because it's the way that you approach everything. It's
Definitely.
that foundational background for, how you go about, solving problems in your life or, approaching challenges. It's
Yeah.
so flexible.
For me, the biggest thing is the critical thinking that
Mm.
comes from it. Not just saying, critical thinking is not no. It's not just automatically disagreeing with something,
No.
which I think is some cases what people seem to think of. You've got to question everything and question the science and do your research. It's like, well, no, it's not. Critical thinking is not that. It's taking the mindset of, okay, who said that? Why did they say that? What's the evidence for supporting their particular way of saying things? And is that evidence justified?
Yes.
The whole anecdotes aren't evidence, especially within forensics. It's hearsay. You can't even submit it to a court of law
Yeah.
unless you're an expert witness, and then my evidence is my opinion. But
Yes.
without that critical thinking or that ability to evaluate the information you've been given, you're very susceptible to manipulation. And I
Mm.
think that's where a lot of the problems within society have arisen, is that manipulation by people that have their own goals and mindset that they want to
Yeah.
get where they want to go.
Absolutely. And part of the whole questioning exercise is also not just asking any questions, it's asking the right questions.
Definitely.
And, if you think critically, you can figure out what the correct questions are to lead you to your next step.
Yep.
And, that's where we should all be doing, what's the next question to ask.
Yeah. Yeah, but thinking about the answers you've been given as well, because it's that
Yeah.
whole active listening thing. You don't
Yes.
just ask a question and you've asked the
You have to
question and
take
you
in what
ignore
you've
what it
actually
is.
heard.
Yeah. You actually take in what you've heard and evaluate that,
Yeah.
and then move on. And
Yes.
yeah, it's a definite
It's
mindset
building.
that
Yeah.
has definitely benefited me, and I attribute it all to the STEM area.
Gosh.
And my dad
Yes.
answering all those annoying questions of constantly he asked when I was a child.
That helps. Yeah, so many other questions I would like to ask you about all this work, but we're going to be starting to run out of time. So let's see. Yeah, so we might move on to some of those soft questions before we
Yep.
run out of time. Cool. So, what hobby or interest do you have that is most unrelated to your field of work?
Uh, there's probably two. I did classical ballet for 12
Ooh,
years growing
that's
up,
cool.
point shoes and all the other bits and
Yeah,
pieces. So I did that from the time I was 4 to the time I was 16.
that's a lot
Um,
of dedication.
it is, yeah, and my feet and hips are
Painful.
paying me back for it now. That being said, I still love the ballet, and my daughter has been doing it for a little while as well. She loves the
Oh, that's so
dancing
cool.
and the ballet.
Yeah.
After that, I started playing beach volleyball
Ooh,
and was a state outdoor beach
nice.
two-a-side player. With my skin tone, it probably wasn't the best of ideas. It was a lot of sunscreen.
Yes, I can
But
imagine.
yeah, so I played state level beach volleyball with myself and a couple of other females. We played tour sides down at the beach at six
Nice.
thirty in the morning, and yeah, it was a lot of fun, and I got a lot out of it. It was one of those things that kept me sane during my PhD. And
Yeah.
during my write up of my PhD was basically
Oh,
being able to go, no
put it
science,
down for a sec. Yep.
beach. So it was good.
That's very cool. So those are very active things. Is that something that you still do as an aside?
It's definitely dropped. My activity levels have definitely dropped with
Yeah.
kids and getting older, but I still try to go for runs fairly
Yeah.
regularly, and I still try to keep as active. I'm not as active as I used to be,
Yeah.
so for me now it's more pushed into the hobbies in terms of running around with kids or doing things with the kids. My daughter has no chance in getting out of the science area because I'm constantly going, let's do this, let's do this, let's do this. But she tolerates me, and so does my
Oh,
son. But in terms of what I do now, it's probably a lot of reading and a lot of just being a person and sort of
yeah.
spending time with my family is probably what I do more now than anything.
That's cool. Oh, that's a nice balance.
Yeah, it is. You got to be a person.
Absolutely. And which childhood book holds the strongest memories for you?
My dad is a science fiction fan,
Oh,
and so he introduced me to Douglas Adams when I was quite
wow.
young. So I read
Ooh,
Hitchhiker's Guide to the Galaxy, and it is still
yeah.
one of my favorite books
Yes.
that I love. Love that. Love the movie, and I've now introduced my kids to it.
Oh, so great.
So Hitchhiker's Guide to the Galaxy is definitely one of my favorites.
Mm.
In terms of absolute real childhood books, I would probably say Horton Hears a Who, which
Oh,
is
that's a
Dr.
good one.
Zeus.
Yes.
It's one of my favorites. A person is a person, no matter how small. So, and that
Yes.
really ties in with my whole
It
mindset of
really does.
people first. Yeah, and
Yeah.
it's I still love the book. My kids have my copy of my book, and we've read it repeatedly since they were little. A little problematic in terms of some of the themes within it, but
Yeah.
for me, what I try to emphasize is that they're all people. They're all
Absolutely.
persons in their own right. The who to the elephant to the monkeys and the kangaroos, they all have their own mindset, and they should
Yeah.
be enabled to do whatever they want to do.
Absolutely. Yeah, that's a good one. And yeah, it's about that lesson. Like that's the important part
Yes,
about the lesson.
that's yeah. I don't like some of the other stuff within it, but obviously the take home for me is a person is a person, no matter
Yep.
how small. So yeah, so you've got the science fiction.
Yes. Yeah, that's cool. Like being introduced to Douglas Adams young, like it feels yeah, a bit
I think it was
childish.
probably
But
because I'd read most of the books in the house, and he was just trying to keep me quiet. So he was like, "Here, have this massive novel," and it was
well, it
it was
works.
just the way he spoke and the way he was writing about things. It was
Yeah.
amazing. It
Yeah,
really sort of
it's
grabbed me.
yeah. It's a certain type of humor. Like it's
I
you've
still
got the
have that
Gamer, the
type of humor.
Pratchett's, the Douglas Adams, and it's that particular style
Yep.
of humor that it's observational.
Yeah.
It's funny, but it's still kind. Like there's nothing cruel
Yeah,
about the humor.
exactly. It's not cruel. It's not mean. It's insightful and clever, which is why I like
Yes.
it. And then I went down the Isaac Asimov and the Arthur
Oh
C.
gosh.
Clarke and all those the Dune series and all those other ones. But
Yeah.
then that was because my dad had the books, so
Of course.
it was one of those things.
Yeah, and yeah, makes you think about things in a certain way as well, because that's the period where they had all that speculative technology and speculative science
Definitely,
stuff. Yeah,
definitely.
awesome. And last question, what advice would you give someone who'd like to do what you do, or what advice should they ignore?
Oh, so this is going back. I do get asked, how do I get your job? How do I do what you do? And my advice is always the same: base science first, then
Yeah,
forensics. Don't get trapped into a degree that doesn't give you employable
options.
skills
Hmm.
and doesn't give you those options. Yeah. So quite
Yeah,
often I have seen in the past some undergraduate degrees that I've been quite critical of, because they get to do cool things, like they can go out and they learn to photograph exhibits at crime scenes, and they do these mock crime scenes, and they do these kind of units that when they're doing them are really, really interesting and really cool, but it doesn't give them employable skills. We
mm,
can't hire them because they're not a chemist. We can't,
yeah,
or the Pathwest guys, the Pathwest staff struggle because they're not biology. They don't have enough. So my advice is always base science first, because if you like that, that's good, because that's what you're going to be doing a lot of. You can then do the cool forensic stuff after, or specialize later on, or just compete with the people that are going to be getting the jobs because you've got the strong chemistry or the strong biology or whatever.
yeah,
So that's usually my advice: base science first.
absolutely. Because it's all about, like, all those other things are cool to do. They add a bit more color to your foundations. They
Definitely.
augment your degree, but they can't exist in isolation.
No, exactly.
Yeah,
Forensic science means science applied to the law.
yeah.
Without the science, you can't do the forensic.
You don't know enough.
So,
Yeah.
exactly. You have to be able to go to court or whatever, understand the science of what you're working with first.
Mm,
Without that, you're going to struggle.
absolutely. Great advice. Okay, and so, well, thank you so much, Kari, for speaking
No
with me
worries.
today. Yeah, running close to time. So, if people would like to know more about what you do, where can they go?
Oh, so there are a few websites that do have forensic areas within them. There is the Australian and New Zealand Forensic Science Society's website, so ANSFS, horrible acronym, but they have a website. So if you Google them, there are some options, and that goes through all of the areas of forensics. It's not
Mm,
just chemistry.
yeah,
ChemCentre ourselves has a website within them. So if you just Google ChemCentre, I'm on Twitter mostly.
yep,
I do LinkedIn, but not much. Mostly Twitter.
yep.
So you can find me on there. But in terms of something a little bit different, I always like to, when I'm presenting or when I'm looking at where I'm going to go and engaging, I also like to push the Deadly Science website as
Yes,
well.
Deadly Science,
So
so good.
Deadly Science is basically bringing science to regional areas. I was born
Hmm.
in a very regional area. I was born in Paraburdoo. We used to have to drive 80 kilometres to go grocery shopping. So
Yeah.
I often do wonder how different my life would be like if I stayed there throughout my childhood. I moved when I
Mm,
was about 5. So how different my life would be now. And so I always like to plug the Deadly Science
of course.
organisation and science and website wherever I can, just to kind of go, if
Absolutely.
you've got a bit of spare money and you've got to be a bit engaged in the science, go to them to make sure that all kids get the options and the opportunities that I got and that I try to pass along to the people that I go and see.
Yeah, absolutely. It's so great because I love what they do because, it is hard to get a lot of resources out to rural areas. And it's such a, you know, it's so disappointing that all these people with all this
It
potential don't
is.
have access to all these
They
wonderful
miss out.
programs and abilities. Yeah,
Yeah.
they
So
miss
my
out.
mum,
And
yeah,
yeah,
my mum's a primary school teacher, and she actually went back to university when she was 50. to do her early childhood teaching degree.
That's cool.
So, yeah, absolutely amazing woman, my mum. Not only did she put up with me all the way through childhood, she's then gone off and done a whole bunch. I've got 2 sisters and a brother as well. But for me, her engaging with the child area, and you know, she gets me quite often to come out and talk to her class. And
lovely.
I know that she taught me a lot about the values and the support that is required to get where I am. And so I do attribute my success to my mum and my dad for not only, you know, moving to where we needed to go for my dad, but also just the support of finding and having that support to find out where I wanted to be. And I think that's a lot of the time an issue with a lot of young kids, is being able to find their own path and find where their passion is. For me, that's chemistry, but I know that it's not for everyone. So what I want, and what I think the Deadly Science guys do really well, is supporting that fascination and supporting that curiosity for all children, regardless of where they are.
Exactly. And just lets them know what's out there for them, even if they, you know, can't reach it yet. At least they know where to start.
Exactly.
It's wonderful. Okay, well, this has been such an amazing conversation, Kari. Thank you so much.
Thank you very much for having me. We might have to do a follow-up in a while.
I feel like I need a follow-up. I've got so many other questions for you, because there's so many things that
I'm happy to always talk.
And it's all sorts of really cool things.
All sorts of stuff. Forensics, you could fall down the rabbit hole and quite happily spend lots of time. And I'm always happy to talk about my job, because it's my favourite part of the whole thing that I do is the science that I do.
Amazing. Might have to take you up on that, because there's so many other additional questions. Cool. Okay, well, thank you again. And
thank you very much.
Such an amazing conversation, and I hope you have a wonderful day.
Thank you. Thanks very much. See ya.
I've loved speaking with Kari about the forensic aspects of the sciences and what the work actually involves beyond the glamour of television. It's also been fascinating to learn about some of the differences between forensic roles and those in research and academia. To learn more about Kari and what we discussed on this show, or to connect with us, please visit the STEAM Powered website at steampoweredshow.com. You can also find Kari on Twitter at Forensic Chem Rocks and LinkedIn, the links for which will be in the show notes. Kari also wanted to make a special call out for Deadly Science, a fantastic organisation that aims to bring science books and resources to remote schools in Australia. You can find them at deadlyscience.org.au. If you enjoyed this conversation, please let me know. Subscribe to the show, leave a comment, and share this with your geeky or geek curious friends. You can also support Steam Powered on Patreon and Ko-fi under Steam Powered Show, the links for which will also be in the show notes. Thanks for tuning in, and we'll see you next time.